It's wonderful to see such a turnout on a Tuesday evening. I believe most of you are coming from your workplace and your college, right?
Yes.
Great. So it's great to have you here, and I think you all deserve a big applause, right? So please clap for yourselves. Thank you so much. My name is Riya Shah, and I take care about the admissions at Grey Atom. So Grey Atom is our EduTech partner for DataGiri. We have worked closely with more than 5,000 students and have helped them to get their transition into data science as a career. It has been already more than, I think, 3 years that we have started DataGiri, right? DataGiri was started in the month of July 2016 with a clear vision to build a community of data science where people are coming, they're talking, sharing what is trending in this field and how can you take a transition with your current career, right? So currently in this meetup, we have close to 150,000 community members. And most of you are here, right? It's great to see. We have been conducting events in Mumbai, Pune, Manchester, London, and many other cities in the past. As Grey Atom, we offer programs which are online and offline as well. Now I would like to invite Mayuresh Shilotri, who is the co-founder of DataGiri and Grey Atom. He will be taking you through what this event is and how this is going to help you. So I request you to please clap for him.
Hi guys. Being mindful of time, we really need to get started. And we learned of some great travel plans for Siraj. So I think we'll skip a lot of these things. My name is Mayuresh. This is a labor of love for me. This whole DataGiri event, each and every one of you coming over here and sharing your time, wanting to receive what is there on this side, from all the people who kind of come from all parts of the world to share what they have. I think that's something that we look forward to, strive forward to, and this is really, I think, the best part of what you do. So, just to quickly summarize, these are not-for-profit community called DataGiri, where we evangelize data science. We want to essentially bring people from industry and want them to kind of speak to all the people who are aspirants, also working professionals. We have sessions which are completely tech and geek workshops. So I think some of you, how many of you attended a DataGiri event in the past? Can I have a show of hands? Fantastic. So I think not a lot of people, but I think if you can stay tuned at meetup.com/DataGiri, I think you'll get a lot of updates about all the upcoming events. So we have events which are 2-hour format, 1-hour format, which are the webinars, and 8-hour format, which are the workshops, which are essentially where you get to learn a lot of these things. So with that, I'll just like to cap it off over here. Thank you so much, all of you, for coming over here. I'm not sure if you've had this kind of arrangements even on a Saturday. So thank you so much for coming over here. And with this, I would just like to invite Siraj, if you can just have a very, very great.
Hi, good to be here. Okay, here we go. Finally. All right. So thank you for coming here today. I'm very excited to be here in Mumbai. I was just in Paris 2 days ago, and in LA before that, which is where I live. So I don't know what time zone I'm in anymore, which is perfect, right? So my talk today is going to be about data science in 2019, which is, I think this year. Yeah, this year. So data science in 2019 is the name of this talk. This is the year, right? 2018 was a great year for AI. There were a lot of people who got into the space. Across every metric, the community increased in size in terms of number of developers, obviously, but also in terms of the number of businesses that are hiring for this very lucrative position. In 2019, if there was anybody who came up to me and asked, what is the way to make the most impact in the world as one single person? I don't have a lot of wealth, a lot of funds, I don't have a lot of connections. What can I do? Well, if you have access to the internet, if you have a laptop, you can perform data science on some data sets, make a prediction, and apply it to some really, really hard problem in healthcare, education, the public sector, so many different industries. And so it's a very exciting year to be alive on this planet, in this reality or simulation, whatever you want to call it. Let's not get too much on this tangent. All right, so let's get started with this talk. So in this talk, I'm going to talk about 10 things that I think are going to be particularly interesting this year in data science. So let's start off with number one, which is client-side training. So generally, when we think about data science, right, we're thinking about some algorithm that we're using to make a prediction using some data set. And when we think of this algorithm, we'll train it on some data set, and then we'll put it on a server. And then this server will be a website, and we'll serve it to people. So anybody who visits this website, let's say it's nameyourcat.com, right? They'll upload an image of their cat, and it'll say, well, it's a cat, it's not a dog. Obviously, that's not useful. This is just an example. And as this app scales to millions of users, this works, right? Server side works. But the problem is that we are moving into a world where there are thousands of sensors that are coming online every day. Sensors, the Internet of Things. That's a buzzword, but it's a real thing, right? And so how do we integrate all of these sensors to make some kind of prediction, whether it's for weather analysis, right? Or whether it's for supply chains, right? Supply chains, different cars and cameras and detectors that detect different chemicals in the atmosphere. How do we integrate all of that data into one cohesive model? Well, we could put it on a server for sure, but then the problem is latency, right? If you have all these disparate sensors spread across many kilometers, across even nation states, that's a lot of data to be training on at the same time. So latency is a huge problem, especially for supply chain, where things need to be very rapid and fast. People need to be updated in real time. So how do we solve this problem? The answer is in client-side training. And so the idea here is that instead of putting our algorithm on a server, we keep it on the device. So whether it's a mobile device, it's learning on your device from the data, or whether it's a sensor, it's learning on the sensor. So what are some examples of client-side training? Well, one example would be a deep learning a USB stick, right? So I just made a video about this recently, but Intel has this product. It's a USB stick. Deep learning's on the stick. Put it on your computer. You train it right on the stick. That's it. So that's one example, but there are several examples like this. So this is going to be more important this year. We're going to see more libraries. We're going to see more products that are using client-side training. So that's super exciting. So this is something to look into if you're interested in the space, client-side training, for sure, because this is going to be more useful. And so what I have here is a graph of what a server-side app looks like, right? So client-side would be the mobile app on the left. Server-side is the server. This could be AWS, Azure, whatever you want to pick. And then it's sending the request, the image is the request to the server, and then it's pulling back the response. The response is the prediction, right? 404, 403, all these errors and stuff. Ideally, though, this model that you would see, neural network, is on the client side. So this is server side, but if we flip that's client-side training. And so if you Google client-side training, a bunch of great resources on that. I also have a video on this. All right, second thing that I want to talk about is Kubernetes. Raise your hand if you've heard about Kubernetes. Oh, okay, nice. All right, this is a pretty technical audience. I like it. All right, good. So Kubernetes is super cool. A lot of people, when they think about containerization, they think about Docker, because that's been it's almost synonymous with the word containerization. Some developers even use the word Docker instead of container, like it literally means the same thing. But Docker is just a type of container. Kubernetes is the new hot type of container technology, and the reason it's so hot is because it's scalable, right? It's scalable to more people than Docker would be, and it's just a great tool to use. I don't know if you guys have used it, but I've actually taken the time to make a very simple app with Kubernetes on my own as I was preparing for a video that I was making, and it's really easy to use, and it scales to thousands of what are called pods in the Kubernetes ecosystem. They call them pods. And it's got a whole architecture, and the documentation is great as well. It's talking about scheduling and controllers and all these things. I mean, it looks like it would be complicated, but the documentation really explains it well. And I have a thing for really good documentation as a technical writer. So Kubernetes is going to be another really hot thing in data science this year for sure. So definitely look into it. The third thing, AutoML. So AutoML was an idea. It was a concept of some algorithm learning about itself. learning how to learn, so meta-learning, right? So learning what the optimal hyperparameters would be, what the optimal variables would be. And what happened was Google took this idea of AutoML and they named a product AutoML. And so there's this kind of confusion between what AutoML really is, but the true AutoML is not their product, it's the idea of an algorithm learning how to learn. And so what this picture shows is what that would be. So the normal pipeline for data science is, you have a data set, you look through it manually and you try to find the good features, you prepare it, you clean it, remove things that are unnecessary, duplicate features, and then you pick the ones that are the best, feature engineering, select your model, train it, hyperprint. So it's a huge pipeline of different things that a data scientist has to do. And the idea behind AutoML, the concept, is that we acquire our data and then we make our predictions. Everything in the middle is automated. So I know what you might be thinking, doesn't this make data scientists obsolete? The thing is, that's AI, data science, these technologies. If anything is going to be automated, these are the last things that are going to be automated of all the jobs. Because think about all the industries that this applies to, right? That's like saying, who's going to take the job of the puppet master? It's like the puppet master is always going to be there. It's like this is not a problem for job security. This is a good thing. This is a tool in the data science toolbox. It's not like replacing anything in a bad way. But yeah, AutoML, the idea of it is something that is very useful to know. In terms of specific algorithms that help do this, I would say augmented random search. That's one. I'm just naming one that's very popular. I've gotten a lot of requests for a video on that recently, which I'll probably do, but augmented random search is something to look up. Okay? All right, the fourth one is unsupervised learning. So, it is time for some real unsupervised learning, right? We have been waiting far too long for this. And honestly, I'm a little frustrated because, it was supposed to be 2018 when we saw some real unsupervised learning happen. And it was only in December, so last month actually, that we saw a really cool application of unsupervised learning. It was Google. They used unsupervised learning for machine translation. So normally when you have machine translation, you have the original text, which is in one language, and then the target text, which is in the next language. And so you could think of the target text as the label, right? So I love you in English, and then je t'aime in French, that's the label, and then you learn the mapping, and then you give it a new English input, and you'll learn how to translate it to French, right? So that's how it's done so far. But the idea behind unsupervised machine translation is that it will cluster different sentences into categories. And from that, it's going to be able to translate. So that's the basic idea behind unsupervised learning, and mostly it's clustering. But this image here shows the differences between them. And for supervised, you have discrete versus continuous. Discrete would be 1, 2, 3, 4. Those are discrete, separate, distinct numbers. It starts and it ends. Continuous would be, it just keeps going infinitely in both directions, forever within, forever without. A little meme for people who watch my channel. Raise your hand if you know that, by the way. Oh, sick. Nice. Oh, shit. That's cool. Yeah, cool. You guys got me high for a sec. So that's continuous. Continuous and discrete, those are the two differences mathematically, but we can apply that to learning techniques. And so dimensionality reduction is the one that I feel like it really doesn't get enough love these days. There are two methods that are the go-to for dimensionality reduction, where you have some data set and it's got hundreds, maybe thousands of features, and you want to reduce it into 2 or 3 dimensions so we humans can visualize this. And I'm going to go off on a very interesting tangent right now. So we can only visualize things in 2 or 3 dimensions because that's how this reality is. But ideally, we would be able to visualize data in its true form, which is in 100, 1,000 dimensions. How would we do that? And the way to do that is a brain-computer interface. So if we think about the progression of technology, right? And we have our desktops. They were huge mainframe computers, and they were made smaller into laptops, which we have now. And then they were made into phones, which we keep on our body at all times. And the next natural progression is some kind of wearable technology, like a watch, which we're having already with all these different electronic watches. The next step would be something that is not separate from us, but the same as us, right? So what would that look like? Well, we would need some kind of interface between our brain and the internet, right? So what we're doing right now when we're typing at 150 taps per minute, the bandwidth, there's a constraint in bandwidth behind how fast we're thinking and how fast we can type, right? Or how fast we can read or scroll down a news feed. But if we remove that bandwidth constraint, we can maximize that bandwidth and be able to think 1000x, create 1000x, discover 1000x, experience 1000x, what we would normally. So that would be the idea behind a brain-computer interface. And it might sound kind of wild right now, but if you think about it, in the past 2 years, 90% of the world's data information was created in the past 2 years. That's all the libraries of Alexandria and all around the world. In the past 2 years, we've created more information than all of human history, and that just keeps happening. So it's almost like we're living in this kind of, we're so lucky to be alive right now when this is happening. Of all the times in human history we're alive right now, where 90% of all information is being created every 2 years. So inevitably, as this, we're just exponentially creating all of these layers of this technology, the chips, the hardware, the software, the protocols that connect these things together. Inevitably, the next step here is to create some kind of device that connects us directly to each other. Don't even think about it as the internet, but to each other. Right? Sometimes you're not able to explain things fully to somebody else because of a communication barrier, whether it's a different language or something like that. But what if you could feel what they're feeling or think what they're thinking or know what that memory is, and they could just transfer that to you directly? So that's something that I'm in particular very excited about. I know that's kind of different from unsupervised learning, but I did want to mention that because it is something that's very important to me, and you will be hearing more about that from me over time. Okay. So the fifth thing is reinforcement learning, right? So I was really excited about RL in 2017 and 2018. OpenAI had their library, Universe. We saw several other libraries, and obviously DeepMind had all these really cool, a lot of press, algorithms beating all these games, DeepMind, AlphaGo, all this stuff. But in terms of the real world, in terms of applications, we really didn't see reinforcement learning being used by the everyday person for two reasons. Number one is it takes a lot of data, right? Number two is that I think there's just not a lot of awareness of how this specific technology works, reinforcement learning. Like supervised learning, easy to conceptualize. Okay, it's just a mapping, input and output. Okay, unsupervised, it's kind of simple. It's just clustering, clustering things that are similar together. But reinforcement learning, the idea of trial and error, the idea of trial and error in a time-based environment, that's something that is harder to grasp. And if you look at the theory behind RL, I'll call it RL from now on, it is much harder. And to me, that's exciting, actually, right? It's exciting that there's more to learn there. There's more theory there to learn. So, policies and these different terminologies that aren't used as much in data science as a field, but we're going to start to see that more. So in Paris, I was there for the Kaggle event, which is a data science platform. And they were saying that they want to add more reinforcement learning challenges this year. So that's another data point to point in this direction that RL will be more important in 2019. So what I have here are several libraries that are going to get more traction, I believe, in 2019. And these are Chainer, ELF, Coach. Oh wait, skip Chainer, not Chainer. That's just there, that's just default. But the rest, Coach, TensorForce, RL Lab, Baselines, and ELF by Facebook. So these big companies that are based in the US, but I believe that we're gonna hopefully start seeing more from India. That would be amazing, for sure. So yeah, reinforcement learning libraries, definitely something to look at in 2019. It's gonna become more and more important, and there's a lot of real world use cases in data science, specifically in financial data. Right, time series data, because that's a space where there's a lot of potential to use RL for. If you think about the agent in a financial environment as a trader bot, there's a time-based environment right there. They can perform a series of actions: buy, sell, hold. There's your actions. So I think that's a particularly exciting space for RL. Okay, generative modeling goes mainstream. So who here has seen that video of, it shows these politicians talking, but it's not really them, it was generated? Raise your hand. Yeah, so that was super exciting, seeing that, and it was scary as well. It was both for sure. But no one really used that in a malicious way, except for deepfakes, right? That deepfakes algorithm. But that was so hard to do. I don't know if you guys have tried that algorithm, but like I downloaded it and because I was making a video on it and I was trying it out. And first of all, it required so much computing power, right? At the time, I didn't have a stack of GPUs locally, so it was just hard to do. But in 2019, this stuff is going to get much easier to do. These generative models. It's not just for images, but for video. And ideally, you would give it. What would this look like? Ideally, you would give it a plain English, plain Hindi input, and it would be able to parse that, what you would want, the semantics of that. So I would say. A room with a blue chair and there's a chalkboard and some lights in the corner, and it would find those. It would use sentiment analysis. It would use natural language processing to find those keywords, turn them into vectors, and find their corresponding images. And then it would turn those images into a sequence of images, and a video is just a sequence of images. And it would be able to generate a video of this space, and you could update it over time. And that's how the creative process goes 10x faster, because you can now generate these videos and you don't need a team of engineers working on this in real time with all the pixels and the shading and the lighting and stuff. So this kind of technology is going to be democratized and more people are going to be able to use it. We're going to see more generative modeling going mainstream. But it's going to be exciting and scary regardless, because we're definitely going to see some kind of scandal with this happen this year, for sure. Which is going to be exciting because that's going to bring AI even more into the mainstream, which is a good thing. And anyway, but let me also say that the whole the magic behind generative modeling are in these generated distributions. So distributions are the word when it comes to generative modeling. The idea is that when we have some data set, we would give it to a distribution, which is a curve over an interval of numbers. And using matrix multiplication or one of these methods, it would apply this distribution to the input, and then it would have a stochastic or random output. And that's what we would want. There has to be some kind of stochasticity in the model so that it generates something that didn't exist in the data before, but it's related to that data, right? So definitely more of that. If I were to say what my favorite model is in this space, it would be variational autoencoders, which are really cool. And also when I was at D-Wave, which is a quantum computing lab based in Vancouver, these quantum computing scientists were talking like all day about, I spent the day there, they were talking about variational autoencoders applied to quantum chips. So they were in particular excited about this algorithm when it comes to quantum because of the speed up that it would provide. So I think that's really cool as well. Speaking of quantum. So this has been a buzzword for quite a while, and it's something that it's almost so abstract that it's hard to even begin to grasp what that would even entail. And you're not alone in that. Even these people who are working on this full time don't fully understand quantum computing because it's based off of quantum mechanics, which I've been studying quite a bit. Actually, I read this book called. And it's kind of controversial, but it's called The Physics of God, recently, that talks about quantum mechanics and about holographic energy bodies that help govern the genetic interactions via quantum entanglement at the quantum level, which helps answer some of the questions that genetics leaves hanging. And in fact, there's the entire field of epigenetics, which literally means above genetics, that aims to help answer some of the questions that genetics leaves unanswered. My point being that quantum mechanics is just weird, and no one really understands it. And there's a lot of different theories around how it works. But quantum computing utilizes these mathematical equations of quantum mechanics to solve problems. And so we're going to see a lot more of that be used in real-world applications this year, I believe, because of two reasons. Number one, a lot of companies are releasing tools that allow people anywhere to use quantum technology. IBM would be one. IBM released it in, I think, 32 countries. I really hope they allow it here in India. Sorry? Microsoft as well, yes, perfect. So, yeah, Microsoft as well. Yeah, and so D-Wave, I told them they should, but they didn't. But that's next on their pipeline to release it here. But my point being that we're going to see more of this because this is becoming more and more available. And in terms of the specific industry that we could apply this to, anything that's a graph problem. These graph problems are very difficult. Social networks, Internet of Things, finding the optimal path, the fastest path algorithm, these kinds of things. How do you get from point A to point B as efficiently as possible? Quantum computing does very well in this space. So more of that. Also, geometric deep learning is another technique for these graph problems as well, which I need to make more videos on. Number 9, new AI hardware, FPGAs. We definitely need new AI hardware in general because GPUs are very expensive, and we need cheaper, lower cost, lower power devices. And actually, I think this would be something that this is something that I would see India coming out with, because India is really good at making cheap, low cost hardware that's better than other, right? So like the space, the moon robot, right? So that's a perfect example right there. The whole world is impressed by that. So this would be a really cool idea, but the thing is, hardware is really hard to make, obviously, right? But with 3D printing and these different technologies like Raspberry Pi, it's easy to prototype with these things. So better AI hardware is something that we all need, and someone who the person who figures that out is going to be very successful. Because GPUs are not good enough. They require way too much power and energy. They really drain your electricity bill. And not everybody is is Facebook or Google or these big companies. So we definitely need new AI hardware. And so AI for good. So the thing is, I feel like we're starting to see more of these companies have some kind of AI for good initiative. Microsoft, Facebook, Salesforce, and even startups as well. It's almost like it's necessary to do something for social impact. And that's a good thing. That's obviously a good thing. A lot of times it's just kind of tacked on, where, Facebook, for example, is like 99% behavioral modification and manipulation and all this negative stuff. But then they'll say, oh yeah, but we're doing good. You're on the corner to the side. And everyone's like, oh, okay. But we're going to see more of that in general. And the companies because people are demanding this. People are demanding, we've seen the negatives of the technology. We've seen the negatives of AI. We know that AI is being used to manipulate people, to advertise to us. It's being used to, make you buy a product and command your attention, because this is an attention economy. That's the most valuable thing you have as a human, is your attention, and everybody is competing for this attention. So how you focus that attention is your power, right? How you focus that attention is your power. So let me go off on a little very helpful tangent here. So something that I do to help prevent social media from manipulating my attention, even though I use it very heavily, obviously, to promote my message to people, is a couple things. So one, I use grayscale on my phone. So grayscale mode means all the colors are black and white. And the reason that I do this is that these UI and UX designers at these companies, very smart people, are spending their days and nights figuring out how to best keep your attention and your eyes on the screen. And it's not about, it's not even about how smart or how educated you are. All of us are susceptible to this because it's a very primal thing. It's a very, it's very nested in our evolution. When we see some particular combination of colors, it's going to trigger some particular emotion or sensation in our body, and they're manipulating it very well, whether it's the shininess of Instagram or the greenness of the creativity of WhatsApp or all these things. So the way to avoid that is to go into grayscale. So what that does is it makes me check my phone less. And when I do check it, it's for utility. So that's one. The other is I turn off all notifications that are not from humans. So there's a lot of notifications that we get from these apps that are automated, like, it's this person's birthday. I mean, that's one example. or this person joined the group, or these things that we don't necessarily need to know, but it just tells us this. So you can turn that off manually on most of these social networking apps. So it's not about just black and white, like just delete all your social media, because then you're not going to be able to communicate with people. But it's about being very smart with your attention and making sure that these apps aren't manipulating you, but you are instead controlling them, right? So, so that's definitely an important thing. Yes, and so my last point about 2019 is my prediction of the 3 fields that I think we're going to see the most progress in. Not necessarily the best field, but the 3 fields that I think we're going to see the most progress in terms of data science. And those are healthcare, education, and the public sector. So for healthcare, so this is one I'm in particular the most excited about, because I spent some time reading this book called 10 Reasons to Delete Your Social Media by Jerome Lanier, who was one of the pioneers of the internet. He was very much a technology evangelist in the 70s and 80s, and he made all of these technologies. He helped develop HTTP, which is the protocol of the internet that we all know and love. So if anybody, and so this guy wrote the book, like why you should delete your social media, which is kind of a dichotomy, right? You would think you'd write a book called 10 Reasons to Download Social Media. It's a future, but you write how to delete it. So that's why I think in particular this book was interesting, because of the person who wrote it. And in the book, he was talking about all the negatives of AI. And when I read that book, I was like, you know what? I'm really into this technology. It's part of my persona. It's part of my. It's me. I feel it's like. So what is that field that I'm most excited about? If there's so much negative, what is it? And so what it is it's healthcare. That is like the most clear example of how we can benefit humanity when it comes to applying these technologies to data sets. And so one example would be genetics, right? So genetics is in particular is a very interesting example. Who here has heard of the AlphaFold algorithm that DeepMind released? Just raise your hand. AlphaFold. Oh, nice. I love talking about this. Great. No one knows about this. So DeepMind is this lab based in the UK. They've just been playing games, literally. They have like 500 of the best AI scientists in the world, and they're applying these algorithms to game worlds. That's it. They just want to beat games. But recently, they applied one of their algorithms called AlphaFold to molecular biology. And so they entered it into this competition called CASP, which I forgot what the acronym stands for, honestly, but it's a competition where a bunch of molecular biology companies, pharmaceutical companies like Novartis and all of these, with 100K plus employees, they have been working on this for years, decades. They have huge teams. And guess what? DeepMind beat all of them at a specific task called protein folding, predicting how these proteins are going to fold. And this is useful because if we can predict how proteins fold, we can create new types of biomaterials like spider silk or all sorts of coating for agricultural, products. And so we can increase crop yields by 100x. We can solve hunger. Like really, if we can predict how proteins fold, we can cure a bunch of diseases like Alzheimer's and tuberculosis and all of these neurodegenerative diseases. There's a bunch. So that's really exciting if we're able to do that. And they were able to beat all of these molecular biology companies in this task. So there you go. And they had no experience. They just had an algorithm. So that was super exciting. And this just happened 2 months ago. So it's a really exciting time right now. So in healthcare in particular, AI can be used to solve a lot of problems. So genetics is one, for example. And I would also, if you're interested in this particular, I would recommend a book called The Gene by Siraj Raval, which he's an oncologist. And he wrote a book. It's kind of like an action movie. He describes the history of genetics and all of these discoveries, starting with the human genome and things like that. And it really puts things into perspective of how there are 3 fundamental units of reality: the atom, the byte, the digital byte, and the gene, right? Biology, information, and matter. These are the fundamental building blocks from which all science and innovation and technology spring up from. And in the 20th century, innovation in these fields distinctly, separately occurred, right? So for the gene, it was like discovering, Darwin's theory of evolution, mapping out the human genome in, I think, 2006. And then for the byte, obviously all these algorithms. For the atom, it was discovering CERN with the particle accelerator and all this stuff. But in the 21st century, it will be the convergence of these building blocks that will define innovation and technology. So combining the gene and the byte, AlphaFold is one example of combining these two fundamental building blocks. And we're going to see more of that this year and next year. So healthcare is definitely a really exciting application of data science, and especially because it's so hard. Like I thought AI was hard, but when I read this book, The Gene, and also just looking through some genetic data sets, there's like tens of thousands of features when it comes to these molecules, and it's like all these like 10x54 like names, like acronyms that are really long, and it makes sense because these biology PhDs spend 7 years learning about this stuff. But like compared to AI, I think biology is way harder than AI. Like in AI, we have simple input output. It's like debug this, that. In biology, there are thousands of processes happening all at once. It's really complicated. So that's the perfect use case for AI because it can find the needle in the haystack, where the haystack are millions of data points. We can't do that. So that's a perfect example. Two more, education. So when it comes to education is very, not everybody has access to education, but if we were able to personalize education, if we were able to create chatbots that, taught people how to do things, it was trained on some data set, maybe, entire books about some specific topic. And then it was trained to be able to say that in someone's native tongue, and it's free and it's scalable. That's great. We can democratize education. 6 million people are coming online this year. Most of them are going to be 8 million. Most of them are going to be in India. So that's going to be amazing. So we have this incredible opportunity to apply personalized education to people who wouldn't otherwise get it, which is very exciting. And the third one is the public sector. So these are all sorts of social services, clean water, sanitation, healthcare is one, insurance is another one, credit scoring. These are all, wonderful applications of data science and technology. So those are the three I wanted to talk about. And that's it, so thank you very much.
Thank you so much, Siraj, for educating us. I believe it was a very informative session, and I think everyone is looking forward for what's going to happen in 2019. Moving ahead, we will be having a question and answer round, right? So where we will be taking the public questions as well, and we'll be discussing about different kind of doubts, applications that you have about the field. Siraj, can I have you on stage?
Thanks a lot for educating us about the advancement happening in AI. So my question is, we are doing this AI for manufacturing basically. We started with one client where we had a lot of machinery, and then second, third, fourth, and then client by client, we basically applied the same, lot of different kind of AI algorithms on different machines data. Now, this question is towards transfer learning. What are the advancements happening in transfer learning? How feasible is it? Is it really, did we dream of bringing down the hyperparameter tuning time to 0? Is it really possible? How much is it feasible? And in general about manufacturing. Thanks.
For sure. Yeah, great question. So transfer learning is something that I probably should have mentioned as well, because we're definitely going to see a lot more transfer learning in 2019. One great example is it's an algorithm called BERT, which is it's a pretty technical name. It's called Bidirectional Encoder Representation from Transformers, or BERT. And so Google released this, I think, November of 2018, so this was 2 months ago. And so this was natural language processing's moment. It was the moment, because what they did was they trained an algorithm on a bunch of text data, more text data than any of us have. And we can use this trained model as a pre-trained model, so then anybody can use this BERT algorithm to train on their own text data with much less. So instead of having to have 1 million different text samples, you would have 100K or less, 10K even. So BERT was really a huge moment in AI. It was similar to the ImageNet moment in 2016, where Microsoft beat everybody else when it came to detecting, image classification. So that was like the ImageNet moment of NLP. That's one that sticks out. But we definitely need to see more transfer learning in manufacturing. The thing about manufacturing is there's so many disparate data sets, right? Machines have such independent features. So it's hard to apply transfer learning there. So I can see your issue. That would be a great, I'm just like thinking out loud, but that would also be a great business, like transfer learning, because it's a clear problem. Like if you would just train on different data sets related to machines. When it comes to transfer learning applied to manufacturing, that sounds like reinforcement learning would be a great opportunity there, because these machines are moving, and so time is a feature in this environment.
Yeah, because ImageNet has been there on images, and then BERT has been there on probably on NLP data, but for probably time series data coming from sensors, probably we don't have anything.
Nothing yet. Nothing real yet.
Nothing real in transfer learning domain.
Yeah, but that's a great opportunity. So if someone here is listening, that's a great opportunity.
Okay, thanks.
Hi. So I wanted to ask how lucrative is the research opportunities, do you think, on capsule networks?
Yeah, whatever happened to capsule networks, right? So capsule networks, to give some background, that was an algorithm invented by the same person, Jeffrey Hinton, who invented neural networks back in, he didn't invent them, but he popularized the optimization technique, backpropagation in the 80s, that makes neural networks work so well. Capsule networks was an extension of an idea called convolutional networks that are used for image classification. And so capsule networks came out last year. And it was, everybody was excited. If we look at that conference, like pictures of that conference where it was released, all the researchers gathered around that particular paper. I really thought there would be more activity around capsule networks, but there hasn't been, for whatever reason. I think it's because I don't think people really understand how capsule networks work. I mean, it's counterintuitive because we're used to thinking about image classification in a certain way, and capsule network kind of reverses that. In terms of lucrative opportunities for capsule networks in particular, there's definitely going to be lucrative opportunities there because computer vision is not going anywhere. And anything we can do to increase state of the art is going to be, everyone's going to want that. So if I were working in computer vision, I'd probably be working in capsule networks because that's the most exciting, cutting edge technology that still exists today. In terms of particular places that would want that, like capsule network based research, I mean, I could name several in the US, but also probably Microsoft. Microsoft India has some great opportunities for that. I would look there.
Thank you.
Yeah, so talking about the first topic you raised about client-side processing. So what happens is that, like, if you take computer vision, I'm trying to solve a problem in computer vision, maybe I will try with resonance. But then client-side inference of resonance, I can face performance issues. So are there any algorithms that are already becoming popular in terms of client-side inferences?
For sure, that's a great question. So I could have elaborated more on some algorithms there. So there is one in particular. It's called SMTP, Secure Multi-Party Computation. SMPC, sorry, SMPC. Right, so that's what I would look into. But the idea is that you can split these ResNets into shards, but it still trains like it's a single ResNet. And these shards live on different clients, like different mobile devices or sensors. And so it's training on pieces of data all at the same time. Peer-to-peer, exactly. To secure multi-party computation, so computation is happening across different nodes. These nodes are devices. And I don't think I've seen it applied to ResNet in particular. That'd be a great project to do. I have seen it applied to feed-forward networks, recurrent networks. And one great example of this would be OpenMind, which is a project I'm familiar with. OpenMind, which is for training models client side, and it uses this technique in detail. It's got some great documentation on it as well.
A couple of questions from me. First is, what is your view on AI-enabled energy specifically, and the other is secure AI. Let's say using homomorphic encryption and something like that. People are working on that, but how long do you think that it will be really secure in the future?
Yeah, I think this is the year that we're finally going to start seeing a marketplace for data and a marketplace for algorithms. And the catalysts for this are these technologies like homomorphic encryption and secure multi-party computation. And I'll throw another one in there, differential privacy. Because people have been working, in separate bubbles on these technologies. People have been working separately on deep learning, and people are working separately on privacy. People are working separately on distributed systems. But it's the convergence of these technologies that are going to enable these data marketplaces and algorithms to occur. And we started to see a lot of traction there in 2018, but I think we're finally going to start to see profitable businesses in 2019.
What are your thoughts regarding face recognition and predicting possible human actions based on continuous observation of humans, like providing security by keeping us, all of us, under 24/7 monitoring?
So in terms of that being a method of data collection, that's a great method because you're getting data, right, for sure. In terms of the morality of that, which is the more interesting question. So China's definitely doing this, right, for sure. Like the elephant in the room. China's definitely doing this. And whether or not, so I've been kind of obsessed with China recently after reading AI Superpowers by Dr. Kai-Fu Lee, which talks about how China is really implementing a lot of this AI technology at light speed across almost every industry from a top-down approach. And if you look at these vlogs of people who go to China and they ask people on the street, like, what do you think about the social credit score system? You feel oppressed by these cameras everywhere that are watching everything you do? And we would think, like, yeah, I guess, of course, they must feel. They generally feel fine. They feel, oh, I'm not doing anything bad. So it's like a cultural thing. And so it's like to them, it's okay. We'll definitely see more of that coming from China. China in particular is, it's a very top-down approach. Sentiment analysis is being performed on hundreds of thousands of people. It's being sent as a single report to the leader, and that's a very efficient way of doing things. For them, for their culture, they have a different set of values based on Confucianism, and it's just different. It's not necessarily worse; it's just different. And a lot of ways they are surpassing the U.S. in terms of R&D investment in certain specific industries. And also, like, if you look in the restaurant, nobody uses cash. Everybody uses their phone to pay, which, like, in the U.S., that's like it's 10 years in the future. And grandmas are getting served food by robots at these restaurants. It's like a cultural thing, right? So, yeah. So that's like how I feel about it. It's not necessarily bad. It's just different.
Hi. Thanks for the talk. It was really interesting. I have a question. What do you think about the progress of AI and machine learning in the world of music and arts?
Yes, that's a great question. Yeah, so a friend of mine, Taryn Southern, released the first pop album created entirely with AI. And she did this using a tool that anybody can use. There was not even code involved. It's called Amper, amper.com. And what it does is it uses generative models to sample from musical data sets. And so it's taking this musical data, which breaks down to just numbers, right? Audio waveforms. And it's multiplying those waveforms by distributions. So it's going to be just a little different. There's some randomness there. And so when you take these and you scale this up across a larger training process, you can get a song that's in the same genre, but it's entirely different. And the more data you give it, the better it's going to get by some objective that you set out mathematically. So that's a really exciting field for sure. Generative modeling applied to music, we're going to see more of that. And we're going to see more artists using this. And the thing is, like, when we're when it'll really become mainstream is when the word AI is not even applied to it. When these artists are using it as a part of their tools that they're already using. And it's just some button that they're pressing on these applications. So I think we're going to see more of that this year. We saw that last year. We're definitely going to see more of that this year. I think in particular the music space that it's going to start off with is in EDM and electronic music, dance music like that, because there's already like this culture of electronic sounds.
Hi. My query is regarding the AI in context to the smart home technology, the IoT devices. So, can you share some use cases of the present scenario in 2019 where AI and smart homes are coming together, and 2 years down the line, how is the trend moving further?
There's one in particular, one device that I personally find very fascinating, and that's there's the thermostat. So there's one company called Nest that's based in the US that has a thermostat that learns what you prefer the temperature to be. So it'll sense when you're home, it'll learn when you're going to leave, and then it's going to predict when you're going to be at home, and it's going to predict when you're going to leave. And it's going to set the temperature accordingly. So that saves you energy and money, which is a great use case. But that can apply to a bunch of sensors in the home besides temperature. Lighting is one example, right? Not just knowing, having to think about, at 8 p.m. just always go off, or at 2 p.m. always turn off. That's not how it is. You come and leave at different times, and so some predictive technique would be better there.
So do you see a technology hazard when it comes to the higher technology of 5G and that radiation and other issues that are being talked about? So you see that in contrast to the use of this technology?
So radiation in particular is a problem even with phones. There have been studies that show that having phones can cause infertility, placed in a certain area or things like that. So there's definitely a problem with microwave radiation, even in our phones. That is a general problem that needs to be solved for sure. How to solve that is a question of energy and not algorithms. But I think an exciting area for that would be in, it's kind of out there, but nuclear energy, I think needs to be looked at the micro scale. I think there's some potential there.
I think we have a question at the back.
Hi, Siraj.
Hi.
Fan here. I have a small company. So we have a small company in capital marketing and applied deep learning there. One of the common sense is that applying deep learning techniques on structured data versus using the tree-based learner, the performance difference is not too much, and the compute cost is probably 10 times, 15 times. And deep learning is still good for your unstructured data, which are more self-contained problems. Do you see a tipping point where the supervised learning technique, deep learning techniques start to be equally impactful on the structured data, apart from any feature engineering being done?
I do, but it's not going to be the deep learning that we think of. It's going to be more graph networks. Geometric deep learning is the buzzword for it. Geometric for the label. There's a whole class of techniques that started to gain traction in 2018 around geometric deep learning that we're going to see more of in 2019. But graph-based neural networks are the future of structured data, I believe.
I think we'll be taking one last question right now. So I think at the back, man in the wagon, right behind the last room. Yes.
So I worked in as a machine learning on education and healthcare data here in India and then in the US. One of the problems you see with education data here is you don't particularly know which set of data you're getting or who you're actually getting into your results. There's a lot of missing data. So for example, if you wanted to machine learning on with machines, as someone else mentioned here, or with Twitter data. You get all of the data all of the time with one. Education, if you're looking at test scores, you don't know who showed up on that day or how they were feeling or all of these other measures. So what kind of things are you looking at in terms of dealing with like missing data for education? And what kind of solutions are you excited about over there?
So missing data is a problem in general, for sure. And when it comes to missing data, data augmentation techniques, synthetic data, data that's generated, that's what I'm most excited about when it comes to missing data. Techniques that generate data, synthetic data, that looks real, but it's actually fake. We've seen a lot of this used for, very basic examples like MNIST, handwritten digit classification. We've seen it at a small scale. We haven't really seen it at a large scale. But it's advances in generative modeling will apply to creating synthetic data for filling in the blanks in missing data. So I'd like to see more generative modeling applied to missing data. When it comes to education in particular, that's a great use case. I mean, it applies to any of these industries.
Thank you so much, Siraj, for educating and answering all the questions that I think most of our audience out here had. Right, so I hope this session was a useful session, an informative session, and I think a good roadmap that you have provided us, right? So out here, I would request the audience to feel free to network with each other. We would be ending the session for today. Thank you so much for being an awesome audience out here and coming late evening. Thank you so much. I just